So this video is going to focus on heat transfer. It's a big theme in our unit on thermochemistry, but I'm going to give you some definitions and some words that we're going to start to use interchangeably going forward in this unit. So the first two words that I want to talk about are system versus surroundings, system versus surroundings. And again, what we're focused on again is what is the system in a chemical process and what is the surroundings. So system is going to be the experiment in the test tube, okay? Experiment in the test tube, okay? So if I have a chemical reaction, okay, what exactly is in the test tube? So that's always going to be how we define a system in thermochemistry, is the experiment itself. So the chemical reaction that is taking place, what is in the test tube, beaker, whatever it happens to be. The surroundings is everything outside the experiment, outside the experiment. So what can some of those things be? Well, it could be the air outside it. It could be the lab bench that we're on. It could also be the test tube itself. It could be the beaker it's in, so on and so forth. It could be Naperville, the earth, the universe, from every place outside of that. So the surrounding is everything outside the experiment. It also could be the water that is in the chemical reaction itself, but that's a little bit beyond our discussions at this level. So when we are talking in thermochemistry, it's all about direction of where's the energy going. So our perspective is always going to be the system. So put a star next to that in your notes. So we're always taking the viewpoint of the system. So we're always saying, okay, is the system going to lose or gain something? So we're going to use positive and negative numbers to show, are we losing or gaining things? So if we're gaining something, it's going to be positive. If we're losing something, it's going to be negative. Okay, so we're going to use system and surroundings to define two key words that we're going to use going forward. And those words are endothermic and exothermic. And we're going to use it in a couple different places in this unit. So endothermic and exothermic, and realize that they're going to be abbreviated endo and exo. That's going to be how they are abbreviated going forward. So it's less writing for us to do. So the easiest one to explain in terms of a chemical reaction is going to be exothermic. This one is far easier to explain than anything else. So please write down exothermic, and again, write down exo as your abbreviation. And what word comes to mind when you think of exo? Well, think of the word exit, okay? So if you think of that word, that will help you to understand what is taking place in an exothermic process. All right, we are losing heat to the surrounding. We are losing heat to the surroundings. So again, if we are the perspective of the system, we're losing something. We're losing something. Another way I could say it is heat is coming out of the system. Heat is coming out of the system. So again, I am losing something if I am the system, if it is an exothermic process. So therefore, it is going to be given as a negative number. Okay, it's going to be given as a negative number because we are essentially saying I am losing something. So anytime I'm using the term lose, I'm going to put a negative in front of it. So we already kind of talked about negatives, but now we're going to use it in terms of exothermic. So exothermic reactions are always going to be negative. Now, this doesn't have to do with necessarily a delta T. This has to do with, again, Q or heat. So exothermic reactions are hot to the touch, okay? Exothermics, the easiest example I could give you is a hot pack that you might buy at I can't think of the word, Osco or a drugstore. You want something to put on your body to relieve some stress, and so it's heated up. If it is hot to the touch, that means that chemical process you are feeling is hot because it's releasing heat. Okay, it's releasing heat. So losing heat, again, loss or losing is going to be a negative thing in chemistry, a negative thing in chemistry. So exothermics are far easier to understand than the opposite. So if you know this one, the other one is the exact opposite. Okay, so that is what we call endothermic. That's what we call endothermic. Okay, so endothermic reactions absorb heat from the surroundings. So the heat is going into the system. Heat is going into the system. And so that is why it is considered a positive number. Again, this has nothing to do with delta T. This has to do with, again, the transfer of energy, So the transfer of heat. So if I'm absorbing heat from the surroundings, I am gaining it into the system. So since I'm gaining something, that is a positive thing. So we put endothermics as positives. So endothermics are positives. So just like exothermics are hot to the touch, endothermic processes are cold to the touch. This one is harder to understand because if you have a system, essentially, and you put your fingers on it, what you are feeling is essentially the surroundings. So if you're feeling the surroundings, it feels cold to you because the heat has gone somewhere else. So endothermics are not as easy to understand as exo, because exothermic, it's like I burn firewood. I get energy coming out. I could feel the heat, okay? But endothermics are the exact opposite. The heat is going into the system. So when I touch it, it's because it is cold because I've lost heat. In that surrounding. So that's, again, the tricky part with this. So endothermic is absorbing, so it's going to be a positive. All right, so just a couple more definitions here. So we've been talking about Q as heat, okay? Well, a new thing you're going to start to see a symbol is going to be a capital H, and you're going to see a delta sign in front of it. So we're going to say that heat is the same as something called change in enthalpy. And again, if you take chemistry again, wherever that may be, enthalpy is a much bigger topic that we cover. And delta H is the same as Q under what we call constant pressure. What that means is, again, in a lab situation, we are doing all of our experiments at atmospheric pressure. We're not changing the pressure of the room. If you do that, it changes how the reaction behaves, especially if you have gases in the reaction. So we are going to start to see something called delta H in some of the different labs that we're going to be doing, and also in some of the calculations. So it's called a change in enthalpy. For all intents and purposes, though, it's going to be the same calculation. But to kind of tie it into what we just talked about, if you see a delta H listed for a chemical reaction and it's a negative number, that is considered an exothermic process. If you see that the delta H is listed as a positive value, then it's considered an endothermic process. So again, exothermic would mean heat is released when the chemical reaction takes place. If the delta H is positive, it means heat is needed in order for that reaction to take place. So again, negatives and positives in thermochemistry just have to do with direction. It just has to do with direction. So again, it's not necessarily the delta H, the delta T's are negative. It means the direction. So when we are doing these kinds of calculations, okay, with Q, we've already talked about MC delta T as our equation for Q. Delta H is going to be calculated the same way. But please, again, note that the delta T is always final minus initial, but that's not necessarily telling you direction as well as you might think. So in some cases, we are going to have to look at that beyond the delta T to say, okay, is it a positive or negative thing? Okay, because again, exothermics, the temperatures are going to go up. So again, the final temperature is going to be greater than the initial temperature, but in an endothermic process, the final temperature is going to be lower than the initial. So again, the negative and the positives are going to get confusing with delta T's. But again, just understand this delta H is going to be the same as Q, okay? And endothermic and exothermic processes,